Hi, my name is Kyle Wankin, student ID 00068163, and here we're going to demonstrate IPsec over securing GRE tunnels, encrypting the tunnels, and we are going to continue all from the GRE configurations that we had before. As you can see here, we have the left hand side and the right hand side. On the left hand side, we have the Windows server. On the right hand side, we have the DHCP client that is getting the information or its settings from the Windows server. The Windows server has the Active Directory domain services, the DHCP server, and the DNS server. Also, we have the client that is collecting the DHCP address, assigned address, which is 172.168.20.21. I have pictures here that I had done preloaded that shows the particular settings. As you can see, this is the Windows server, and we have the least addressed, which is 172.16.20.21 for the Windows PC. As you see, it is least, right? We can actually go on to the PC here and see the actual DNS IP address. So I did a DHCP IP config all, as you can see up here, and as you can see, the DHCP is enabled, and this is the DHCP address that it got. As you can see, the DHCP server and the DNS server, you see it right here, which is actually the IP address 20.2, 192.168.20.2. right here. This is the Windows client. Alright, I'm just showing you these things up front. This is the Windows server, which is what I showed you earlier on with the DHCP. Least address also has the Active Directory information. Alright, so we can tell it's functioning, but what we're really going to focus on here is showing you the configurations on the routers, and to show that the tunnels were set up with IPsec, and that we can get to see how the IPsec tunnel, the encryption works, and that's how we can see that it's actually working with the packets. Okay, so we are going to demonstrate how we're going to show you the configs on the routers. Each particular router here, R1, R2, R3, R4, so that you can get an understanding for what we did for each one of these routers, so you can see. Okay, so let's start with the two routers in between. All these routers were configured with IP addresses /30, right, which is 255.255.255.252, because there's two hosts in between all of them. Okay, so let's start on router 1. As you can see, we have the configs of IP addresses on the interfaces to match. This is the default gateway for the 192.168.20.0/24 network, and we have the default gateway, which is 20.1, which is 172.16.20.1/24 network. Okay, and we have our GRE tunnel the two interfaces F01 and F00. As you can see, R1 is configured, the tunnel is configured with 192.168.1.1/30, and R4 interface, which is interface F00. The tunnel, the virtual tunnel, right, on the interface, it's configured with 192.168.1.2/30. Okay, so we have our routers. So let's go on each router. I'm going to start with R2 and R3 as they have less configurations on them. So we have R2. As you can see, we have our OSPF fully loaded adjacencies. Let's just do a show run and we quickly go through the settings. So we have our interfaces F00 and F01. As you can see, they are configured with IP addresses that are also here as well. R2 10.2 and 10.5, they are both here. We are also going to show you the routes that were created. We have these routes that were created. The network is 10.10.10.0, and we have the 10.10.10.4 network, subnetwork. This is the 10.0, and this is the 10.4 network. Those are the network IDs. We're going to go to R3 now. As you can see, they are fully loaded adjacencies. And we're going to do a show run. As you can see, we have our IP addresses 10.9 and 10.6. As you can see here, 10.6 and 10.9. We'll show our router OSPF processes. One, as you can see, the network is a 10.10.4 and a 10.10.8, all prefix /30. And we also have our network for our tunnels, which we left network for the tunnels. We have the 192.168.1.0. okay, I don't think this one had it, but then again, it did not affect. Yes, we had the network for the tunnels as well on R2. Okay, so now we are moving on to R1. R1 will have a lot of configurations on it, as it is part of the tunneling process. It also holds a lot of configs for the IPsec process. So we're going to go through it all at once. So you can see the IPsec configs, right? What we're doing, what those configs are for the tunnel on IPsec profiles. We're doing the IPsec profiles. So we have the first set here. We have configured GRE over IPsec, IPsec over GRE using a tunnel IPsec profile. Right, so we set up, put the settings here, okay, and then what we did is configure the transform set. So this is this part here, the transform set, with the information for encryption and for hashing. Encryption, right, the hashing didn't show up in the configurations, but we have authentication pre-share, group 5, PFS, right, and the PFS is perfect forwarding secrecy, also called forward secrecy, refers to an encryption system that changes the keys used to encrypt and decrypt information frequently and automatically. Right, we have the mode. We also, after we set this, the VPN transform set, we set the mode of transport, which is the mode that just encrypts the entire payload. Alright, so we use the mode transport, which encrypts only the IP payload while keeping the original IP header intact. This mode is less secure than tunnel mode, as the IP header remains on encrypted transport mode is commonly used for end-to-end communication between a client and a server. Alright, so we have the mode transport. We also have the crypto IPsec profile, which is what we are doing here, and we named it VPN GRE, and we set the transport set for that particular profile using this transform set here with the encryption and hashing. Okay, moving forward, what we did also is that after we created the interface tunnel, which is the IP address 192.168.1.1, as you can see 255.255.255.252, we give the tunnel source, which is the 10.10.1 physical interface, and the tunnel destination, which is 10.10.10.10, which is on this side on router 4. We also did a tunnel protection IPsec profile, which is just adding the actual IPsec profile VPN GRE that you saw earlier on. We had the interfaces configured with the IP addresses, as you can see here. The F00 interface with the 192.168.20.254 and the fast Ethernet 01, which is the 10.10.10.1, 255.255.255.252. We also have the IP address helper address set on the interface that is facing the interface here, that is actually facing the client side. For when the client tunnels across, it will actually see that this is actually the helper address from the actual server, and it will receive a DHCP service to collect the DHCP IP address. We also have our router configured, or we have a passive interface which doesn't allow the OSPF communication on this side of the network because there are no other OSPF routers. We have set up the network so that it will actually receive the network 10.10.10.0, which is the network address for this actual link state interface. OSPF is a link state interface. We have the network for the 192.168.1.0, which is the actual tunnel the tunnel IP address, the tunnel network, which is the network address, and then also we have the network address of the 192.168.20.0. All of these networks are connected to the actual router through their nodes on each side. So what will happen as OSPF continues talking to each other, as OSPF algorithm keep talking to each other, they will populate the OSPF table, and they will all eventually learn about all of these. We also created a static route, which is IP route 172.16.20 network. So we are telling this that this network over here on the right hand side will be available from accessing the last hop on the router address, which is the last hop, which is 192.168.1.2, which resides on the tunnel on this side, on this interface, right? So that's how you get to access that network. And then we create an access list which permits, as we said, the 172.16.20 network, right, via the access, so that the 172.16.20 network can access the subnet of 192.168.20.0. So we created that access list. That is right, and then that was created for the tunnel interface. Okay, so now we are moving on to the R4. R4 will have similar configurations, but it will just be the opposite of R1. Okay, as you can see, we have our adjacencies. We can see that the IPsec is actually working because we already did the configurations. You can see it right here. The ISACamp is on, and we actually are getting adjacencies from the router on the next side. From the tunnel, obviously the router in next side, we router ID from R1. If you look up here, the router ID, as we said, the router ID is the 1.1.1.1. So on R4, we can see that we are getting the adjacencies formed. Alright, so what we're going to do is move forward there and show the configs on R4. So as you can see, we have our settings for the IPsec settings. Similar settings on the other side, just the IP addresses are different for the sources or the destinations, as you can see. Alright. We also, as you can see here as well, we created the tunnel and we gave it an IP address, which is 192.168.1.2. We are saying that this tunnel source is 10.10.10, which is the physical interface here. The destination IP address is the interface IP address for here. And we have the tunnel protection for IPsec profile VPN GRE, which is configured here with the transport set, which it has all the information for encryption and hashing and for pairing the networks to be able to communicate. As you can see here, this router ID is 2.2.2, the router OSPF process is 1. We have the passive interface, as I said, is not to allow any communication with any other routers on this side because there are none in the OSPF process. And we have our networks configured. As you can see, we have the network broadcast, the network address, which is for this network here, which is at 10.8. We have the 172.16.20 network on this side, the right hand side, and we also have the network for the tunnel, which is 192.168.1.0, and these are the wildcard masks. As you can tell, this is 255.255.252, and as you can see, we're using, it's just 2 hosts on that network. We also have a direct IP route 192.168.20 that we are telling us that if we want to get to that network, you have to go on the next hop, which is this side here of the tunnel, which is 192.168.1.1. Same thing configured and vice versa. We also have the access list to permit any traffic that is coming from the 192.168 network, right? Okay, so that is the configuration on the routers. So what we're going to do now is that we're going to generate some traffic so that the routers, we can test out to see the IPsec, how it works, to show that it's generating traffic. Alright, so we're going to put in the password here. I'm going to use a ping command to generate the traffic. So we're going to ping. This is on the client side. As you can see, we have the DHCP working. We're getting a DHCP address on this client I showed you earlier on. Right, as you can see, DHCP is enabled. Yes, auto configuration enabled, and it gets an IP address. They're showing you the DHCP server, they're showing you the default gateway. So we're going to ping the DHCP server on a continuous ping to generate traffic so we can test out the IPsec tunnel. So I'm going to put it on a continuous ping. As you can see, it's pinging the server, and the server we're going to do vice versa and ping the client, which is 172.16.20.21 on a continuous ping as well. So here we have the ping going. So let's go on the router 1 and the route R1 and R4, and we're going to put in our command to test to see how it works. So we're going to say show crypto IPsec SA. As you can see, we're going to get some information here. What we can tell, well, we're going to do it a few times so that we can see how much traffic it generates. Right now there's 599 packets would have passed. It would have passed encapsulated. It would have been encrypted. It would have also packets that coming in decapsulated 798, decrypted 798. I was running the process earlier on, so you would have seen a high number of packets coming in and out. So I'm going to R4 as well. Show crypto IPsec SA. As you're going to see, there is 894 encapsulated packets, encrypted 894, and decapsulated 691. What we're going to do now is give it a little while, and we're going to run it again on both routers, and I'm going to show that how has increased with the amount of information coming in. So okay, so we have done another show crypto IPsec SA, and you can see this particular one, there's 750 encapsulated, and previously there were 599. We're going to do R4 as well. So now on R4, to show that there's enough traffic coming through, there is encapsulated 1,229 and decapsulated 816, and before it was 894 encapsulated and decapsulated 691. So we could tell that the pings are generating enough traffic. Okay, so we have demonstrated how the IPsec is encapsulating and decapsulating and encrypting the information coming across the tunnels. Okay, we can also see that the computer is able to ping on the opposite side of the network and is passing through a secure IPsec tunnel. Okay, so we can previously we showed that the computer can contact both sides of the network. I'm going to show you guys the proof. So we have done a tracet as well from the Windows client, and as you can see, there were 3 hops. The first hop was the actual default gateway. The second hop was the actual tunnel gateway on the next side, and the last hop was the actual Windows server, and we did it also on the Windows server. So on the Windows server, we actually did a tracet as well to check to see where the path that the packets take. And as you can see, we passed the 192.168.20.254 interface on the actual GRE, the actual router, R1 router, and then it went over to the R4 interface, 192.168.1.2, last hop, and then it actually hit the client machine 172.16.20.21. Alright, so I hope this was very informative. Thank you very much. And that was my presentation on IPsec over GRE Tunnels. Thank you.